Hello, I'm Susan Nash, AAPG, and I'm really happy to have the opportunity to have a little bit more time with Ademola Fagade and talk a little bit about solutions to our looming crisis in energy. Ademola, could you tell us a little bit about yourself?
Of course. Thank you so much, Susan. I'm Ademola Fagade, CEO of Geoprime Energy. I really appreciate the opportunity. I've been involved in AAPG for quite a while, and I really love the forward thinking processes and putting together to give industry pioneers like myself and my colleagues a chance to take the front stage and make change. A little bit about myself. I'm Nigerian. I grew up in Nigeria, came from a very innovative, primarily entrepreneur-based um, uh, family, right? And so my
Oh,
family were in the civil engineering and construction business
nice.
for quite a while. They built bridges, banks, and my grandma was actually one of the pioneers in the textile trade industry in Lagos. So
Oh,
we
that's huge. I've heard all about
yes,
I mean,
yes.
it's famous. I mean, for being so innovative and women's industry.
Oh yes, oh yes. She was loved. She was a huge philanthropist. As a matter of fact, I went to my cousin's wedding in London not too long ago, and she had doctors, lawyers, politicians coming to just show respect because she sent them to school. I had no idea
Wow.
she helped so many people. So she's my hero. I lost her about a year and a half ago, and
Oh,
she's a really good source of inspiration. So of course, my family, they were in different other businesses, and I was expected to also go into civil engineering, but I took a liking into electricity, electrical works, electrical engineering. I built, mini boats by myself as a kid. I got electrocuted a couple of times, got in trouble quite a lot actually.
oh no.
And and I was kind of like a an African version of Greta Thunberg, right? Without the signboards and the rest. I would get on stage a lot and pitch about global warming, climate change, and I would call to action, but no one did anything. Um,
I love it.
so I took such a liking to my physics teachers, like the people who inspired me, and I asked a lot of questions. I was quite annoying actually. Um, and I finished school pretty early, high school pretty early, and I got a degree in metallurgical and materials engineering in University of Lagos.
Oh, nice.
Yes, and so that broadened my thought process as to what I wanted to do. Right, I was a little
Hmm.
bit confused in the beginning. Would I be pre-med? Would I just be an engineer? Would it stop there?
Hmm.
Um, I got very interested in nanotechnology, mechanical engineering, and I
Oh,
decided,
cool.
you know what? I want to come to the United States. I want to be a scientist, like whatever it is, a scientist, right? And so, coming here, I saw a shift in industrialization, right? I noticed, in some aspects, we were a little bit more advanced in terms of, innovation and thinking forward. But in other aspects, the US was, by far just so much more better. Things were, in a sense, a lot more organic, a lot more practical back home compared to
Right, right.
the negative effects of industrialization, right? Or I don't want to say capitalism, but um, I saw that we had amazing infrastructures here in the U.S. The power plants, for example, they were built strong, they were built big, they were built for a lot of capacity, right? But to know they weren't paying too much attention to what it did to the environment, right? So
Right.
it's such a big question mark. Like, where do you expect all that carbon to go, right? And so I became so passionate, like bottom line obsessed about energy. And when I started at Wayne State before I graduated, I really wanted to work for an energy company, right? So closed my eyes, prayed, and I got into DTE.
Oh, cool.
I got into DTE. Honestly, Susan, it did not feel like a job. I no, I was home. I deliberately went department hopping, right? I learned from a lot of people. I made a lot of friends. Obviously, all of them older and wiser and a lot more experience than I had. And so, process control technology, distribution operations, fuel supply, like IT, it helped a lot, right? I was able to go
Right.
full circle and understand this industry, right? Even as a base level engineer, because of my enthusiasm, they I was able to spearhead, high risk, high value projects, homeland security based projects. So I led the primary service transformer mitigation, Hirschman mitigation as well, which involved about 5 power plants. I've worked in huge coal plants, and I really enjoyed myself, to be honest. After COVID, I went on to Consumers Energy, and then finally Pratt Whitney. Pratt Whitney, I was one of 2 simulation engineers helping to simulate their Air Force Base in Asheville, North Carolina. I
Oh,
saw,
interesting.
yes,
Wow.
I saw just how lucrative government contracting can be, right? How, beautiful it is, so to speak. And I started my company. So Geoprime Energy's first contract was to help decommission Sinclair power plants. Uh, uh, DTE Sinclair power plant is a coal power plant, right?
Oh,
So
that is so interesting because I mean, a lot of people are it's sort of dismayed by the fact that we're getting more natural gas fired plants, but then if you realize it's actually in place of the coal fired plants, it's really a better option.
yeah. Oh my God. Yes, it is like significantly better, trust me. And and cleaner for the environment, and so
Yeah,
it was a different level in terms of learning for me, right? Because now I'm not an employee. Now I run a company. My first employer became my first client, and I had to somehow make them proud. And so I was paired up with Neil Mortensen. He built the first microgrid, hydrogen microgrid,
wow,
in Michigan. Very, very innovative. He's basically like my second dad.
nice.
We bonded, over a lot of things, business and personal. A great man. And we had a lot of problems, very manual and mundane problems. Things like current state, future state plot diagrams. And I was able to track how it affected the entire project, right?
Yeah,
I was contracted to just engineer the entire project, but I was able to see how bigger companies, Black and Veatch, Tetra Tech, Metro, how their hands were tied because there was a roadblock somewhere down the line. So,
right.
no matter how hard you plan for these high value, high risk projects, they get so complicated that you always have to leave a buffer because things are
Oh, exactly.
things are so variable, and that
And
could
also multiple pathways for everything.
correct, exactly, and that could mean safety, that could mean a contractor's life, that could mean
Yes.
up to $1 million a day in fines,
Well,
right?
especially with considering random stuff with supply chains, because
Yes.
you don't know what's going to happen with whether it be COVID or tariffs.
Yeah. Oh yeah. Anything can happen, right? And so
Yeah,
it's really it's like surgery. It is like surgery, right? You just have to be as detailed as possible. And it gets harder and harder the more you throw manpower at the problem, which was, that's how we solved it back in the days. You have such a huge problem. Okay, let's find as many experts as we can and throw them at the
right.
problem. But if you have all those experts waiting because someone failed to plan properly, then you still have to pay these experts, and they're quite expensive, aren't they?
Well, it's
Yeah.
true. And the more experts you have, the more opinions you have, then you get blocked.
Yes, yes. So, I learned a lot, and I thought to myself, there has to be a better way. Like I want to thrive in this industry. I want to learn
Mm,
more. So I started to do some research. I went back to Tech Town. So Tech Town is an organization here in Michigan.
mm.
They're tagged at Opportunity Zone. So they get some federal dollars, some grant money. They work with institutions to help founders like myself.
Okay,
And they advise to do customer discovery. So because of Tech Town, I interviewed and consulted 135 energy executives across the US, right?
that's
Hey,
great.
I need to understand your problem. I need you to break it down for me because I'm going to test multiple hypotheses to see how we can solve
Right,
it,
right.
right? And so not only did it help me narrow down those problems and find corresponding solutions, it made me also reinforce my knowledge as to how to develop power plants, microgrids, DERs, right? And so with
Mhm.
a good network of advisors and all of the efforts I made to find a solution to innovate, right, in this space, I became a lot more confident in what I was doing, right? So that experience made me develop that software, Synafox, that actually helps
Okay,
manage
okay,
manage the energy
that
assets, right?
I totally understand that now because I was
Yes.
wondering, it's like, okay, what was the impetus or the original um well, no, I wouldn't say trigger, but the original reason for
Yeah. That exactly was the reason, because it's going to take more than just, innovation, right?
Hmm.
It needs a holistic view. A good CEO would say a company is like a wheel. It's like a well-oiled machine, right?
Yeah.
But tell me, why is it that when we want to commission a new plant or decommission a plant, we are hiring up to 12, 20 different contractors with different processes, right? With different experience to take on different verticals, right? It's that you're taking a process that should run smoothly or is expected to run smoothly, and you've siloed all the key parts, right? There will be lack of
Hmm.
communication, there will be delay, right? Discrepancy in processes, right? So what we've done with Synafox is to be able to create an umbrella, right? One layer of a very, very advanced, very, very, fortified operating system, right? That
Hmm.
not just creates increased visibility, right, but is able to cater to the entire life cycle of the energy asset, right? So I'll explain to you in a
Right.
minute how it works, but I can start to run through the slides now that
Yeah,
I've given you a quick background. So let me share my screen here.
okay, that would be great. And the other thing too, I just wanted to mention too, I think that you were speaking of leaders and leadership. I love the fact that you started by talking to um, like 150 different leaders,
Yes.
because you're able to avoid the issues that you have, like that some leaders have, of just creating an echo chamber,
Yes.
and then you're able to break open the silos. Sometimes the silos persist because they're highly efficient
Yeah. Yeah.
within the organization,
Yeah.
but then they don't communicate. So,
Correct, exactly, and that would eventually just become a flaw, in
mhm.
whatever system you create, right? And so, I always like to, reference, in the early 50s, the South Korean War. Nigeria as a country, I'm from a country that happens to be the world's fifth largest oil producer, fourth or
Yes,
fifth, right?
yeah.
We were a superpower. Our currency was worth twice the British pounds at a time, and a lot of great countries today borrowed money from us at the time. We donated a lot of money to South Korea for their efforts, for technology, for food, for innovation.
Wow, wow.
South Korea is a lot more advanced than Nigeria right now, right? One word, they were able to leapfrog, right? They were at point A and they removed all the obstacles, and they did like this, and they worked hard, and they thought only of the future. So every other countries, and however ways they did, different things or ran their government, they wanted to do better at all times,
Oh
right?
my gosh, exactly. And that reminds me too of Japan and the Meiji Restoration.
Yes, correct, correct.
Yeah.
That is the exact same thing. And so I think about the same thing with, the energy industry.
Hmm.
Yes, it's very easy to get so comfortable with the process that we're in today, right? But if you think about some of these coal plants, they were built in the 80s, in the 90s, and they're so old, so mundane, and it's like just slapping on band-aids on different, parts of it to make sure it works. Eventually it's just going to implode, right? So even as we decommissioned St. Clair, we found things that we could not explain. No documentation. No one had any idea, because
Oh
everyone
my
at
gosh.
that time who knew anything about it, they're not alive today, right? So
Yeah,
it's
long
so
gone.
interesting. Yeah, so interesting. So here we are. We're
Yeah.
Geoprime Energy. We aim to power the future with advanced and reliable energy, right? So we are a clean energy technology company. We have different verticals as to how we provide power, microgrids, DERs, and also a little bit on the transmission side. We are very interested in using cutting edge technology to aid development, maintenance, and operations. We optimize wherever we can, in a very reasonable manner. But we are planning to cater to data centers, right? Even though right now some of the things in our pipeline is more smart cities and high energy consuming facilities.
Oh yeah.
So we already spoke about the energy crisis, a little bit more about that. We have two different sets of problems, in my opinion. One with underdeveloped countries, they're lacking the ability to leapfrog like they should, right? We've had some underdeveloped countries say, hey, we can maybe build a coal power plant. And it's just like, why would you do that? It makes no sense to make the obvious mistakes of, another developed country. You should leapfrog. And,
Mhm.
whether that's the reason or just because, industrialization is quite slow, right? Which is, it should be bidirectional, right? Because energy triggers industrialization. All these countries, Africa, for example, gets less than 2% of all energy-based investments in the world, which is wild, right? But even in general, right,
Mhm.
we still get just 15% of global energy investments, to be concentrated on, clean energy, right? So the reasons are obvious, right? We want to help in, in the efforts to, bring in the next generation of energy systems, right? The reasons why we're stuck in this generation is because one, it works. Two, it costs way too much to build to maintain. Think about a company like DTE has 3 coal power plants that needs to commissioning, has maybe 2 gas plants, 1 nuclear, and they're behind on meeting the demand of their customers, right? They have to
Mhm.
increase tariffs, right? They have to increase tariffs every now and then, just so they can, find ways to, augment and replace generation capacity. But if you really think about it, they cannot decommission and build at the same time, even for
That's a
companies
really
that
good
big.
point.
Yeah,
Yeah.
some people would say DTE or companies like that, like they don't like them. Why are my bills going up? But like I really sympathize with them because they are stuck with such a huge problem, right?
Yeah.
But that's where, small companies like myself, we're able to come in and actually help solve that problem, right?
I love it.
If we can replace your generation capacity with microgrids, right?
Right.
Not only can we bring energy systems closer to where it's needed, right? To
Right.
slow down the need for transmission.
Yes.
We can also buy you enough time, right? Not only would it be clean energy, we'll buy you enough time to be able to decommission and replace your own generation capacity, right?
Oh, perfect.
Every time you don't, as a large scale company, utility company, every time you don't meet demand at peak times, whether it's in the peak of the winter or the summer, they have to go into the market and buy energy. That's why everyone's
Mhm.
tariffs increases, right? It's inevitable, right? There is always going to
Yeah.
be a need for energy with increasing, with aging infrastructure, EV adoption being increased, data centers being built left and right because everyone wants to use AI and advance with AI. The energy crisis is serious. It is imminent, right? And it's not just about technology. Hospitals could starve, right? One blink could mean someone else's life, So it's
Well, exactly. And I would say that even if we were to stop and say, okay, no more data centers, et cetera,
right.
still with the aging infrastructure, as you pointed out, the aging infrastructure, aging transmission, burgeoning communities, exurbs, et cetera, we're still going to have a crisis.
Yes. Well, no, 100%. And it has to be a collaborative effort, right?
Hmm.
There's been a question of, would you be a competitor? Like, I'm not looking to be a competitor with the big utility companies. Like, I want to help, right? I'm not ashamed to say I am almost nothing without DTE, for example, right? I learned a lot from them, and that was the real compensation, if you ask me, not a paycheck, not, it was the experience,
Hmm.
the chance to learn the way that I did, right? I was really obsessed with everything that I experienced. So, building the next generation of clean baseload power infrastructure to replace legacy fossil fuel systems, right? Um, you would ask questions like, well, what about solar? What if we just cover the entire, the whole world with solar? Thing about solar is you can't do much with solar without, BESS, without battery, right? And what happens at night, right? And how reliable is solar? Can you power a whole city with solar? Well, solar is more suitable for grid following systems, right? Meaning it augments, right? It's an interconnection play. It's
Exactly.
bidirectional, as opposed to base load power that just
Hmm.
feeds directly into the grid that can be a lot more reliable, right? So the goal here is to be multi-fuel and modular, right? So solar is very
Right.
valid in certain places while it's needed less in others, right? And so nuclear is another question. Oh, why don't we just build enough nuclear plants? Well, there's still a sort of like a negative stigma around nuclear, given the past experience. And, we can argue that it's getting better, but it still takes quite a lot of time to build and it's extremely expensive still, you know?
Exactly. And even though they're trying and they have new technologies,
Yes.
Most of the new technologies are not here in the US,
Hmm.
some are, but in any
Yes.
event.
Yes. It's I hear about Japan, for example. They plan to, I don't know if it's by 2030 or 2050, plant power half of the country with ammonia, right?
Mm,
And they are making strides, right? So
wow.
we have been in contact and currently talking to IHI in Japan.
Mhm.
So last time I was at AAPG, actually, um, the second day, remember I had a meeting that was with IES. It was a
Oh, nice.
subsidiary. Yeah, it was a subsidiary of IHI in Houston that I had a meeting with, a configuration meeting for
That's
energy
great.
systems. So, we're doing everything we can to stay, ahead of, all the new technology and new innovation, and so we can collaboratively work with the best to bring these, cutting edge technology to the right customers. So here are some of our team members, just some. I couldn't fill up the slide. But
Mhm.
Joa here, he's part of the Synafox team. He's a professor at North Carolina A&T with, his faculty supporting the project, development of that software. We have some of his PhD students working for us as well. We have some fractional people here, but also good friends. My CFO, Tim Schaefer, also works with Lila Ellens here, and they're a killer team in terms of just keeping me in check with operations and finances. Michelle Merrigan, more government relations. She's also a prime contractor for the DoD and DOE. All right, so Dr. Lide actually was able to help us with a lot of workforce and institutional integration at University of Michigan, right? He's a sustainability professor. And Danny Ellis is the former CEO of SkySpecs, great friend, helps with investor relations and things like that. And you already know about Neil Mortensen, sort of like the grandfather of our team. Very, very great guy. I mean, he taught me a lot, to be honest. I don't even give him enough credit, but very grateful for this man. He was also one of my bosses at DTE, former director of IT at DTE, currently a PG&E, and is just a project finance genius who just happens to be my cousin, right? So we have quite a bit of people. As you know, I'm a new lab company. We have a lot of support from the new lab ecosystem, from the generator ecosystem, and it's been quite a journey, right? We have a couple projects in the pipeline. Some we're sourcing funding from, some we're just trying to take on by ourselves. Two of those are data center projects. One very interesting one is about powering biotech facilities that require like a lot of energy. And we're powering three right now, or getting ready to power three, in hopes to use that network to power literally almost all of the other biotech facilities those chain of investors have helped to develop, right? Because we would solve a problem exponentially once we can tackle those three verticals. So very, very excited for what's to come, and it's all thanks to my team, right? So we in a nutshell, grid resilience, cost optimization, scalability, sustainable generation, right? Not only are we combining a very robust tech stack in terms of how we are multi-fuel, like provisioning for the fuel supply, but also modular, right? I mean, we're partnered with Pratt Miller, for example, and these guys, they were able to put fuel cells in a tank for the DoD, right? And those are our partners, and that's the level of engineering that we can assure our clients, right? And so it's just very, very exciting to see how we can push, the edge, in terms of what we can deliver. So our applications, right? Earlier I mentioned how we're very bullish on ammonia. Ammonia is such a blessing, and it's a no-brainer in a sense, in the pursuit of utilizing hydrogen to power the future, right? Why haven't we used hydrogen? Hydrogen is one of the most volatile substances on Earth. It is one of the most available substances as well, right? But I remember asking my physics teacher when I was younger, hey, why don't we just have hydrogen cars? And he said, no, that's stupid. You can't think about that. It'll explode in your face. It makes no sense. I was like, huh, maybe he's right. Like, no, it still doesn't make sense. But you can burn hydrogen in a lab in a controlled setting. Why can't we combust with hydrogen? Right? Remember, I told you I was a very annoying student. I asked a lot of questions. Asked a lot of questions. And so when I came here and I asked more questions and dug deep, I saw that people did try to use hydrogen.
Hmm.
but they try to
Oh,
use
yeah.
green hydrogen, right? So green
Right.
hydrogen is electrolysis, right? You get green hydrogen through the electrolysis process. You're separating, the hydrogen and oxygen in water, essentially, right? It requires an immense amount of energy, right? You have to, there's an energy input into that system, right? To be able to separate that, right? And you need a lot of water, clean water, right? You need a lot of special alloys for the anodes and cathodes. And you have to be able to do that in scale, right? Not so practical, is it? Right. But if you think about carbon-based fuel sources, they are very common and very well trusted because of the hydrogen content, not the carbon content, right? Methane gas is CH4, right? But it's the H, the abundance of the H, of the hydrogen in there that makes it, abundantly used in the way that we use them. So it brings us to different other forms, right? If not electrolysis, if not green, but not so green hydrogen, blue hydrogen, steam methane reforming, right? That essentially just involves separation, a separation process from methane, which you use catalysts, and it could be plasma torches, right? You're basically separating the H from the C, right? So CH4, you nuke separation collection processes to be able to repower the system, and whatever you have as residuals, you collect, right? It's a lot cheaper than electrolysis. You also have turquoise, which is a lot cheaper than blue hydrogen, right? Or clear hydrogen. The issue now is, say you find the cheapest way to collect hydrogen, how do you store it? How do you ensure it? Those are also problems people found. It is so volatile that you need very specialized containers to store this hydrogen. Because if they're not sealed enough, if they're not hydrogen proof, that's a disaster waiting to happen,
Oh,
right?
exactly.
Yeah.
Yeah. And
Which,
just like explosion, but also just corrosion.
oh yeah, oh yeah. It makes it really hard to insure, right? You want to be able to insure your projects. You want to be able to guarantee to investors, to customers, that these things are safe. I've seen a lot of style applications with hydrogen despite that problem. People have converted, tractors and equipments to, that are ice-based to use hydrogen instead of gas, and it's worked to a degree, but there have been some very like costly accidents as well, right? It costs a lot of human lives. Unfortunately, sometimes in science, that's the price we have to pay. But what really helps you, sort of defeat that problem is research, feasibility studies, and being pragmatic with everything you do. So in terms of cost, we're about $4.60 for green hydrogen. For clear or turquoise, it's in the range of 13 cents a gallon, right? There's also gold hydrogen, which involves microbes in depleted oil wells, of
Right.
which you can,
Yeah.
use that collection process to have the microbes eat the carbon residue, but excretes the hydrogen that you collect. That's about 50 cents a gallon, right? So there's so
Mhm.
many creative ways, and it's just so beautiful to see just how people are innovating in this space. And there's nothing more important to us than staying on top of it and making sure not only do we understand, but we can also implement different strategies to ensure that we bring this to the needed industries, right? So when we use ammonia as a hydrogen carrier,
Hmm.
and then when we are turning um, aerobic systems to anaerobic, right? So
Hmm.
controlling how much carbon we give out, right? Quite frankly, there are so many innovative ways um, to collect and carbon and turn carbon to byproducts instead of having them be waste products, right? And a quick example is this diagram we have here. This is simply just showing us a process of which you could use. This could be plastic. This could also be, just crude oil. But this is an anaerobic system, right?
Right.
We're not giving off any carbon. We're collecting the carbon, right? As you can see here, we're able to drop carbon-based materials, plastic or what have you, into this furnace, and we're able to start to separate aluminum, silicon, ash, right? All of which have their value, right? We can power this system with renewable ways, right? And then with plasma torch and catalyst, right? nitrogen to
Mhm.
cool the nozzle to control temperature, we're able to then collect hydrogen gas. By the
Mhm.
time you collect hydrogen gas, you have carbon black. Carbon black is very valuable. With carbon black, you can get graphene, which is also extremely valuable.
Yeah.
We need graphene for high tech, right? Um,
Yeah.
as far as hydrogen is concerned, because it's so volatile, if we have our nitrogen feed in here, we get to gas blend and compress into ammonia. We can store ammonia in a we can store ammonia at scale. It's safer, it's easy to ensure, right? Not only can we crack that ammonia back into hydrogen and use it to power our systems, we can use ammonia. There are already ammonia turbines that we can use right now. And ammonia can be
Well,
used for fertilizers, jet fuel, and what have you.
and usually the complaint is that, for example, in the production of ammonium fertilizer, it takes extremely high temperatures
Yes.
and lots of energy. But the way that you're doing it, it's minimizing the cost.
Yes. I mean, by far, to be honest,
Mhm.
if you reference that diagram again, you can see that we can do that from plastics. We can also do it from natural
Exactly.
gas. We can do it from
Yeah.
natural gas. We can do it from depleted oil wells. You
Hmm.
know, the science is there. We just needed people. And I'm not going to take credit for. I'm not Albert Einstein or whatever the case is. Like there are a ton of people doing a lot of research on these things. And a lot of papers out there. You know, it takes, you know, just the boldest minds to then create the right systems to make it work, right? And so that diagram has been repeated in a lab in Denver, North Carolina, Denver, Colorado, works, right? Works safe,
Hmm.
it's anaerobic, carbon capture, and you're turning waste products, formerly waste products, into byproducts, right? And so Synafox is that, you know, the operating system piece that I told you about, you know,
Right.
and I'll get to that very briefly as well. But the you know, the way we apply our technology is, you know, the first step is a feasibility study. The feasibility study would help us, you know, look at not just the economic viability of the project, but like the tech stack. You know, we would understand exactly how, you know, what kind of fuel source we would use for each of our projects, and you know how we can make it modular and truly sustainable, right? So we're bullish on, you know, all of the icons you see here, which, you know, solar, wind, geothermal, and steam to scale, steam turbines to scale, right? So IHI's LM6000 can, you know, produce up to, you know, 100 megawatts per unit, which is just a game changer. And we need this regardless of how we innovate with hydrogen or ammonia. We need to start here if we're going to cater to data center companies, of which, you know, they require up to half a gigawatt to even take a company like mine serious, right? So they need half a gigawatt minimum. So that's huge. That can power, you know, cities, right? And so if that's the minimum requirement for one data
Hmm.
center company, you have data center companies. I'm talking Google, Amazon, AWS, Meta. They they are requiring things that can power like multiple zip codes, right? Per data center, which, you know, also speaks to how much more energy we need pumped into the grid. The
Hmm.
truth about it is we need these data centers isolated. They should not be tapped into the grid, any grid, not ERCOT, not MISO. They should have their own power sources. That's the practical way to go about it. So our products, we have HGO1, Hybrid Grid O1. So this is a electrification system designed for high consuming energy facilities, right? It'll be able to create stable, reliable energy supply that can be sold back to the main grid, but would also create grid resilience for, you know, the off-takers, the facility. You know, it's bidirectional, meaning it has an interconnection play.
Hmm.
Typically, you would have to engage with the utilities. That way, you know, we use their infrastructure to sell back to the grid. You know, they will buy back from us at peak times. And should in case, you know, we need power from the grid, we can also still connect to and buy, right? So this 1.2 to 10 megawatt microgrid could be configured to either be, you know, hydrogen fuel cells or piston engines, which, you know, we have proven that can be extremely clean, very sustainable. Even though we have to start with natural gas, we can phase, you know, a hybrid grid system to start with natural gas and eventually just be 100% hydrogen, right? So very, very beautiful, very scalable, and modular, right? So these come containerized
Yes.
as well.
I love the fact they're modular. And so how many can you modules or how many of the quote boxes can you put?
The truth is there is no limit to how many we can. It's just practicality. What's practical? Are you
Hmm.
are you better off doing 10 HGO ones, or do you want to go up a scale and do one or two SGO ones, right? So we needed to configure smaller boxes, smaller containers, because for a manufacturing plants, they wouldn't need 50 megawatts. In some cases, they need something, small, something, that they can, have budgets for, and also something that can also essentially pay for itself, right? Because if you're also selling back to the grid over time, you will pay for yourself, because
Right, right.
you will qualify for carbon credits, right?
Yeah.
And so the opportunities are phenomenal, and the growth potential is also exponential, right? So
What's so amazing is that, well, say for example in Texas, Enchanted Rock has natural gas fired. They're reciprocating engine generators, but they're not like yours. But the fact is they use them as backups for like HEB and the huge grocery chains and warehouses. And then they also use them for rebuilding after the floods this summer.
yeah, yeah. So that would similar application, only these can run almost as efficiently as a functional microgrid, like a stable 24/7 power system, right?
Okay.
Yeah, and you can choose to turn it off for maintenance, and when you do, because you do have to, for plant maintenance, you still get to buy from the grid, right? But
Okay.
the beauty is in the peak of the summer and the peak of the winter, when during peak times for the utility companies, they would need to tap into the energy market and buy power. And you would also be connected to the energy market. You're connected to the grid bidirectionally, and you can also generate and sell power, right? So
Well, yeah, and every state's a little bit different, but like in Oklahoma, Oklahoma allows lots of rural co-ops, electric co-ops.
oh yes, oh
And
yes.
so those would be ideal because what ha Oklahoma has is a lot of stranded gas a assets that the price has been too low or the volumes are too low to get into the high pressure gas pipelines and they just can't do it. So they just sit there. And
Wow.
and so if you could have, but yeah, they're located, for example, near Tulsa. Tulsa needs energy, and or near small municipalities that are serviced by the rural co-ops, electric co-ops. So just
Yeah.
negotiate a deal with the co-op.
Yeah, yeah. I mean, that's such a huge opportunity. So if we were to tap into such a market, right, we don't need to move natural gas around. If it's just sitting
Right.
there, if they have gas reserves, we just go exactly where those gas reserves are. But we'll
You
take
just
it.
go to the gas gathering system that's sitting there lying fallow and dormant because of the low prices,
Yeah.
fire it up, and there you go.
Yeah, no, 100%. Most definitely would be the way to go. And we can go a step further and, create, generate hydrogen from those natural gas
Right,
reserves,
right.
which would be significantly cleaner than just burning
Yes.
natural gas, right? So,
Right,
I mean,
right.
now call it, just exponential innovation or revolution, but the answers are there, and these things are proven, right? There are multiple
Mhm.
countries, multiple other organizations that have proving what I'm talking about. You can actually turn natural gas into hydrogen, and you have, up to 95% less, carbon emissions, right?
Hmm.
Instead, you have byproducts, right? You have graphene. That you can
Exactly.
sell,
Exactly.
so it's such a beautiful thing. But I'm glad we're here. I'm very, very passionate and very, very honored to be a part of the movement, to be able to help industries, help governments and individuals see the truth, but not just see it, but also like help develop and bring this to market, right? It's such a beautiful thing. So
Oh, I'm really excited about it too.
so
It's so exciting to see what you're doing.
thank you. So SGO1, right, is a tier up from HGO1, right? So 10 to 50 megawatts, um, pretty much similar configurations, only this is now further designed to be islanded, right? So this could
Hmm.
be bidirectional or islanded, meaning you can have it bidirectional where it sells back to the grid, or you can have it standalone, right? Because we are able to configure up to 50 plus megawatts, right? And so A tier above SGO1 is then a data grid. So the data grid is these are just straight power plants designed for data centers, designed for exactly what they need. We want to design these to be primarily just base load, right? So this is where the LM6000s, the bigger unit steam turbines come in. Some of these turbines are able to be multi-fuel. As of right now, to scale hydrogen fuel cells all the way up to 0.5 GW, that might not be as economical as we hoped. So we would have to, in some cases, still utilize natural gas, right? But we could have a blend with hydrogen, which also helps with efficiency in general. So for these, starting at 100 megawatts, we're able to scale up
Hmm.
to 2-3 GW. And at this
Hmm.
point, I mean, once you're above 50, you're not building microgrids anymore. You're building power plants, right? So designed
Right.
to cater directly to data centers. So this slide is just showing a proposal that we are working on for Randolph County, North Carolina. Um, they offer great incentives over there. And we've been talking to the EDPNC. I actually have a meeting next week in person with them to see just how fast we can get the ball rolling. But it's we have some very business friendly, forward thinking states like Texas, like North Carolina, that would give you grants and land, some other state incentives like state appointed project manager to ensure permitting and all those things go smoothly. So we're taking full advantage as much as we can in North Carolina, here in Michigan. But we're also looking at one particular project in Lassen County in California through a venture studio partner of ours. The rest that we have here are just, I can send this slide later. They're just, case studies highlighting the, LM6000 turbines, how they work. We highlighted Synafox, exactly how this works, but I have a separate deck to run through that with you, so I won't waste too much time on this. Methodology, obviously planning and feasibility, making sure we, spend as much time planning and, getting our pre-engineering documents done, our PMPs, our, permitting plans, stakeholder communication plans, things like that. Typically how projects of this size or of this nature would go is we either go raise some funds from some equity, project-based equity rounds to get the project pre-NTP, right? Pre-notice to proceed, meaning we have secured the land, we have secured our vendor commitments, right? We've put some down payments down. We know exactly what the lead times are and what equipments are coming for the technological stack. We have taken care of a degree of permitting work, hiring is done, and the design drawings, right? There's a whole pre-NTP list, and we take care of that to a certain degree. We become what we like to call bankable. So once you're bankable, you have a project on paper, right? You have a project that any investor or any bank would respect, so to speak, right? It's not a pipe dream anymore. You can actually sell the project at pre-NTP stage because it's valuable as it is, right? And so we take that to the bank. We're able to use the same project as collateral and get bankable, right? So that's when we, raise a 20 to 25% equity round, project-based equity round to get pre-NTP, and we stay liquid, and then go to the bank and we'll be able to just push and get some debt to cover the rest of the project. And that's typically how a small company like myself will be able to succeed in building and developing such a project. Oftentimes, what we've been seeing lately is, say when I'm like up to 80% complete, 90% complete, investors will swarm and, try to, buy the project off our hands. Or if we complete, the original investors would, try to not just put in, sorry, before we complete, they will not just put in equity, but also guarantees for those bank loans. And that means they will own a lot more. I mean, we can end up splitting ownership with investors 50-50, of which they could then buy out the rest of the project and own it completely by the time we complete and commission, right? So always open to every model right now. I mean, we're still a small company. We don't actually have to own these assets. But I want to be able to be extremely competitive, be competitive, and be as innovative as possible and help leapfrog, and not just I don't need to be the best. I need to also show the best that these things are possible, because this is a global crisis, a global problem, right? And so I want to be as collaborative as possible. Planning and feasibility studies, EPC, procurement, hybrid smart controls, commissioning and startups. So, a lot of these things we specialize on, and we also partner with the right organizations to help us see to fruition. Our business model, we're looking at development, EPC, commissioning, PPAs, EAAs, government contracts, right? So remember Michelle Merrigan, tremendous experience, as a prime contractor herself when USAID was still a thing. She did projects, energy projects all around the globe, right? She is a powerhouse, a great mentor of mine as well, right? And so we are partnered with the Apex Accelerator organization to help clean up our government contracting mess. We've started getting a lot of IRFPs in the mail. So we're looking to, once we get some personnel help actually, to, hire some more people for the sake of capacity. We would like to have a government contract business unit, but we are looking at a total addressable market of about 800 billion. The serviceable for us is 400 million, right? Such a great industry to be in. I'm glad I chose this as a passion. Our traction so far, we've been at this for about 8 years. And Geoprime Energy itself, I think it's about 2 years old. We've completed 2 subcontracts with DTE Energy. We don't have 2 LOIs anymore. It's actually 5 MOUs is the current updates. We have
Wow, good.
yeah, we have things in the pipeline, and it's looking good, but man, these business cycles are quite long. And so
Hmm.
yeah, it's just we just have to keep at it and secure the deal. So plan and feasibility studies, EPC, we're always doing those. So I completed 3 plan and feasibility studies for underserved communities in Africa this year, right? There was no contract attached to it initially, but now we have the Ondo State government interested, and we're currently applying to get a license to exclusively power an entire coastline, right? So that was a huge win for us this year as well. Some of our partners and supporters. So Pratt Miller, like I said, DoD contractors acquired by Oshkosh. I think they make about $120 million in revenue annually, but they are prime engineers in terms of innovating hydrogen fuel cells. We're quite a small team. We need people that have excelled in defense tech, in mobility, in motorsports. They have the experience. They're able to handle these hydrogen systems with precision. It just makes so much sense, right? So they are, they're the best right now for us. And so MQ Advisors, that's Michelle Merrigan's organization, Welcome Miller Energy Services for workforce development. We have some connections to NERC, just to make sure, even though we're a small company right now, ensuring that we are, implementing best practices so as to avoid what every power plant or every utility scale company would hate, which would be those fines, right? NPower is also an organization helping workforce development, Aprios with data. We are housed by New Lab and leveraging New Lab's connection to essentially, get windows of opportunity into the Saudi Arabian government. Also different other states, right? So I'll be in Brooklyn next week for Climate Futures. Geoprime Energy has been, showcased. And then New Orleans as well is also another energy corridor that has a New Lab branch, of which we get to leverage all 5 New Lab locations and scale accordingly, right? So we started from Tech Town. ERM helps with, some of our permitting works. University of Michigan, North Carolina, and Wayne State as well for workforce. So I have a couple case studies here. No need to like run through them, but we've studied a lot of other different projects and attempts to bring innovation to this space, and we've learned from their mistakes, right? We've and all of their successes as well. and ensuring that our configurations they change accordingly, and we're not stuck in our ways, and we're truly innovating, right, while having checks and balances with the right other organizations as well, right? So if you think about Black and Beach or Tetra Tech, I mean, these companies have been around for decades, and they also have a ton of data in terms of experiences. And so having companies like that as our EPC partners essentially helps de-risk some of the other things that we might have missed, so to speak. An example is Jan Barker. Jan Barker is an Austrian company, GE related company, just like IHI. They actually mandate that we use their EPC partners if we use their piston engines, right? So Clark Energy will be the ones, handling the engineering, procurement, and construction of these equipments to our spec, of course. And so partnering in that sense gives us a huge edge. ERM, MK, Pratt Miller, Synafox, Keysight, those are some other partners that we have. So in terms of investment roadmap, here's where we are right now for Roundup, North Carolina. This is the estimated project size for 250 project cost for 250 megawatts. And so currently we are raising a project-based round for about 15 to 20% of this project to be able to get to pre-NTP. Danielle is former CEO of SkySpecs, heavily connected with AWS, Google as well. We are working on getting power purchase agreements from from their data centers to be able to guarantee this project, right? So the good thing about investments like this, yes, they have such a huge, they're huge in size, but we don't need all this money to come from an investor. We need just a small percentage so they can come in as partners, because once we get pre-NTP, we're bankable, right? And we will be able to guarantee the banks because we have a power purchase agreement signed, right? So sounds complicated, but it's actually pretty straightforward. And I guess we've learned that, within, projects like this, you're using a lot of proven methods, and a lot of EPC partners were extremely credible, like Caterpillar, Baker Hughes, Cummings. They do pretty much do the same things. You sort of de-risk it because you have the right angels on your shoulders, right? Like, you're partnering with the right people. Now, earlier we discussed having multiple companies tackle a big problem in a siloed manner.
Right.
Yeah, it's this is how it's been done for such a long time, and yes, mistakes have been made, but we still see success, right? We plan to take efficiency and optimization further by ensuring that on the planning and feasibility side, and then on the development side, and then the operations and maintenance, we're able to implement Synafox, right, and be that layer of operating system to increase efficiency across the board. And I'll show you that in a second, right? So this is the use of funds. Nothing too much to explain here, other than that it reflects our financial modeling as to how we plan to use these funds from breaking of ground to commissioning. So that's the spiel about Geoprime Energy. I'll touch on a little bit about Synafox to show how Geoprime Energy essentially uses this as an edge to excel, right? So currently focused on government contracts and data centers, in some cases, smart cities and municipalities. And we have a list, and I can send you this deck if you want to have it.
Yeah, I think that would be good because honestly, this is such a detailed deck. We could spend hours. We've gotten right about an hour right now.
Oh, yeah. Okay. Well, in that case, I'm going to wrap this up because you can always reference it. But if you don't mind, I want to spend like 5 minutes running through
Yeah,
what
let's do it quickly because I don't know how many we don't know how many people will stay for an entire hour.
that's very true. So we synchronize, optimize, and transform with Synafox. I already explained the energy crisis, so I won't go through that again, right? But $1.2 trillion lost annually from operational inefficiencies, right? Inefficient resource utilizations, lacking predictive tools, and legacy systems lacking flexible integrations, right? The opportunities for that. So unlike your traditional SCADA system, spreadsheets, manual oversight, pi tags, network switches, which in some cases have proven to help. but they're usually costly, inefficient, and give rooms for compliance issues. And so we create a living digital twin, right? A real-time predictive model of these energy assets to model the operations, right? And so how we really do this is by utilizing our proprietary large language model, Synagogen. What Synagogen does is it's able to learn operations. It's going to aggregate data from all of the data sources relevant to this industry, and then take what you need as a client, as an off-taker, for example, to then cross-reference, find that optimal path, right, for efficiency. And how do you get that optimal path is by testing different scenarios, right? So you create the parameters that needs to be tested. And what you're doing here is in minutes, you're able to run a simulation of what happens if you choose each of the different verticals. What that does is aggregates your fault history and find your optimal path, right? So the engine works by data collection, right? A bidirectional cloud data lake, of which one is the industry data lake and the other is a client data lake. Your output is then now stress tested, right? Multiple scenarios being ran. And then from there, you then create your digital twin simulation, right? And so once you create this, we use HITL, human in the loop, to pair all of the key verticals, the key submodels to all of the, functional human contributor, right? In this case, could be the compliance manager, it could be the operations manager. They get to use, a piece of a unified model, right? So what used to be a siloed effort is now coming from one fully thought out process, which makes a huge difference, right? In how we implement this, right? So a new feature that we added here is a control box. This control box essentially utilizes sovereign AI, right? A lot of people understand the importance of optimization utilizing AI, but the truth is there are a lot of data leaks, and for industries like this, it's quite risky to utilize AI because you have cybersecurity threats, and also you risk hallucinations. But with AMD chips, right, which in this case could be just an exact mirror of what the NVIDIA chips can do, right? We create our own sovereign boxes, right? Which is able to connect to all the SCADA systems, right? All the Schneider Electrics, all the ABBs, all the Siemens, right? And run and streamline unified data, increase visibility, right? Of which in real time, you can see stats, you can go into a dark cold room in a power plant, and instead of risking, high temperatures or, high pressured danger, you're putting on augmented reality glasses that is connected to that control box, the control box that is enhanced with AI, and also connected to all the existing SCADA systems. You've completely de-risked the processes, because while you're predicting damages before they happen or maintenance before it's needed, but you're also able to pinpoint the solution. There's only one example I'll give here. When I was at DTE, we had a huge problem with our primary service transformers. We actually lost some of our servicemen. And this happened because of a very, very small problem. DTE is old, and when they first started, they were a very huge company. Some call them a monopoly. They split into DTE, became Detroit Edison became DTE and ITC. One handled transmission, the other handled generation and gas, right? So there were a lot of information that had to split between these two companies. Discrepancies. On one end, you had certain nomenclature mirroring another, right? And oftentimes, because they shared assets, they always had to exchange. Now, think about turnover. Think about different engineers, some finishing their works before they leave, others not, right? Over the years, there were so much data discrepancy within their systems and with their maps, with their data collection systems, Maximo, EPRI, all the ERM systems. And so, unfortunately, an example of a serviceman going to a primary service transformer with a particular nomenclature that mirrors another, right, in a
Mhm.
sense, and they thought they turned it off, but it turned off the wrong one, and
Oh, wow.
he gets electrocuted, right?
Oh, no. Well,
These
these
Go
things
ahead.
really happen. Yeah. Well, okay. So unfortunately, I have to make a phone call, and it's almost
Oh,
5 o'clock.
Yeah,
and I have to make a phone call before 5. But I was wondering if we could just sum up the Synafox story in just a couple of sentences.
of course. Well, the punchline is this serves as an operating system, right?
Yeah,
A safety layer in terms of efficiency to ensure that you don't just have increased visibility, but you're able to cater to the entire life cycle of the energy assets, right? So we use digital twin simulations, large language model, and AI enhanced control box to achieve this. So I will send this deck to you as well, so we don't take
that's great.
too much time. But thank you so much for you know creating the time to create this recording.
Well, no,
You know,
I'm glad that we had a chance to do this because there's a lot to it. And I know that if we had 3 hours, we could easily fill that up too.
yes.
But I think what's good about this is that we can put different chapters on the
Hmm.
on the recording so people can skip around and watch the part that they really find useful. And I think this will be good to have. I think you frozen. Oh,
Okay.
are
Okay, you're back.
you
I
suddenly
didn't hear you for a
froze?
second. Yeah.
Okay. I just think what we can do is I can break it into chapters
Okay.
and in the recording and label
Yes.
them so that if somebody doesn't have an hour to watch it, they can jump to the parts that are
Yes, I think
relevant
that'll
to
be good. But thank you so much. I know that was quite a lot. We did spend quite a bit of time in the beginning talking
Well, that
doing
was
the
good though. I
introductions.
mean,
Yes.
to me, that was super interesting and
Yeah.
really important.
Of course. Thank you so much, Susan. And I can send you these slides for you to have as well,
Okay, great. That's
if they
good.
need to. Yeah. So
Yeah,
I appreciate
absolutely.
it. And looking forward to our next AAPG engagements.
Me too. Well, thanks, Ademola.
Great. Okay, I'll talk to you later. Bye.
Bye.